Well, welcome everyone. My name's Dan Gallagher. My title is a technology facilitator. I'm in a school district in New Jersey. I'm currently stationed at an elementary classroom or an elementary school as their tech coach. But I've run the gamut from K to 12, working in different school settings, different districts, as well as doing some graduate professorship work for instructional technology. What I'm going to be showing you today is how I've kind of incorporated Tynker and created kind of like an app smash of some different tools to be able to work with the students on coding. We're fortunate enough that we have robotic cars called Probots. And these robotic cars help us with teaching students how to program a robot. But unfortunately, with the last couple of years with the pandemic and COVID, we haven't been able to use the robots hands-on as much. And so what we've had to do is come up with other ways. And so Tynker has allowed me the opportunity to be able to kind of virtually create that experience. So I'm going to kind of walk you through what I've done. Right now, what you're seeing on the screen, that is a Nearpod code if you wanted to get a self-paced and look at it on your own. But I'm going to be kind of bringing up and switching over and kind of walking you through what I put together and what I've done with students so that they had an opportunity to still virtually participate with our Probots. So I'm going to kind of switch over the Nearpod. And so what I'm basically doing is I'm using Nearpod, Tynker, and Flipgrid to kind of create this experience for students. So we kind of start off with the Nearpod with going over the different terminology that we have. So loops, conditions, things like that. So we do what's called a time decline. And I'm just going to start it up briefly just to kind of give you an idea to see what it looks like. And so the students are filling in, they're checking off the vocabulary that we've gone over. And after they've gone through those 11 questions, we then move into a drag and drop. And this is kind of where I'm refreshing for them how Tynker operates using block-based coding. Because eventually the idea is once they get comfortable with block-based coding, we're going to then move them into doing text-based coding using Python. So for this activity, what they need to do is select the correct blocks that would finish out this program to allow the Probot to move around. I've included audio with my directions to kind of help the students that might be struggling. But what they would be doing is they would have to figure out, since I want them to draw a square, they're going to have to drag in the repeat 4 times. And they're going to also be dragging in the different blocks that they need to finish out this program. So they're going to repeat it 4 times. They're going to move 100 pixels, then turn 90 degrees, and that's what's going to then create the square. Once they've finished that, I've got a little video kind of introducing to them what they're going to be doing in Tynker. And so they would watch that video. I do have some pause points in the video asking some different questions, just as a reminder so that they make sure that they know what they're doing. So for instance, they're going to be signing in with Google. We're going to be having them draw a square. They're going to press the space bar to be able to erase the picture if they want to try again. So then what they have is they've got a link that's going to bring them to this activity. And so the activity looks something like this. So I already have the code set up for them. What they're going to be doing is they're actually going to complete this. And so when they run this program, it kind of walks them through. My Bitmoji kind of gives them the different directions. Once they do that, they then have to enter in some of the criteria. So when I click on the Probot, so they're going to decide what they're going to draw. For this one, I want to do a square, so I'm going to enter the number 4. I'm going to go 150 pixels. I'm going to turn 90 degrees, and that's kind of why I have that chart there on the side to help them out. because this is done in elementary. This is like third and fourth graders. They're still working on angles with their shapes. So it's helpful to have that little kind of cheat sheet there for them. And then it does the activity. It draws. Probot moves out of the way. When I'm ready, I click the space bar, and I can then continue on. So now that they've had a chance to experience it, now I want them to be able to build it. And so going back to that Nearpod, what they're going to get the opportunity to do is reflect on that coding. They're going to see an example in Tynker of code, and they have to then see what's going on and talk about how they would debug it. And that's what they're going to record in Flipgrid, is how would they debug to get that code working. Once we've finished with that, we then get a chance to go in. And what I love about Tynker is they have the ability to have these tutorials. And so I have some items already set up and created for them. So if I look over here, my avatar already has some code here to kind of kickstart and initiate this activity. And as they go through this tutorial, it walks them through the steps so that they can do different changes and modifications to make it their own. And as they go through, sometimes they're going to get to pages where, on the stage, we have certain things that we need to drag out. And so in this tutorial, the students are able to drag the blocks out that they need, and they can then edit. And maybe instead of the up arrow, we're going to use the space bar. And as they go through this tutorial,
creating a geometric shape. This is where the fun begins. We need to put our math map.
Put that on mute there. I'm able to have audio recorded to kind of read directions to them, but they can't move ahead until they've actually dragged out those blocks that they need. And so it helps them build their own program. And I have everything in there for them that they would need. And the directions up here tell them how they would set it up so that when the question is being asked, whatever response someone enters, that is then used as the degrees for turning or the number of pixels to move. And so this tutorial kind of walks them through how to create that. And so I'm actually going to, since this is mine, I'm going to get out of the tutorial. I'm in edit mode so that I can go to the 5th page. And so now this is their finishing touches. They have to test it out before they turn in the link to me to their finished version. They need to try it for a couple of different things to make sure that their Probot will actually do what it needs to do, how it's going to operate. They're able to, I have my avatar, my Bitmoji is my avatar there, but they can go in and they can edit the costume and they can put in a different picture. They could use something that either they draw, or they could import their own picture and image that they have on their Chromebook, so that they can then build this activity out. And, we're going over different things like conditionals, being able to have questions asked and get responses from anyone that's participating in your activity. They're being able to utilize a lot of different functions that Tynker has available. If I get out of the tutorial, but you can see here they have all these different events, controls, operators. So you're able to bring in all these different things. What I also really appreciate, since our actual Probots have the ability to have a pen and you're able to draw and have a dry erase marker in there, and I'm able to have the students draw on the floor their different shapes with the actual robots, Tynker has the ability to have a pen included in with your sprite that your character over here. And so you're able to have your character, no matter what it is, whether it's a robot car or anything else, be able to have that pen incorporated in so that you're able to kind of mimic that same functionality virtually. So that was the activity that I kind of app smashed together to incorporate Tynker and be able to have students be able to replace something that we've done hands-on in person but now be able to do it virtually. So I'm going to look into the chat to see if there are any questions from anyone. I don't see any questions.
So I wanted to ask you, how long were you in education, and how did you get involved, or how did you choose Tynker?
So I actually, today was our last day of school. We had a half day. So I finished up my 16th year in education. I got involved with Tynker mainly because when I changed school districts and I started 2 years ago in a new school district. They were using Tynker as their coding platform. Before then, I was not familiar with it. I was always relying on code.org, which provided coding lessons for students, but I was not able to ever really adapt and create my own activities. And then that tutorial aspect built into Tynker. So when I came to Milburn, my new district, when I saw that they were utilizing this platform, I dove headfirst in and went all out. I love any way that I can bring in coding into other aspects. So with the robotic cars, able to bring the coding with Tynker into that. We also do breakout activities using breakout boxes. And so sometimes I've created digital clues using Tynker. And then when students go and create their own, they remember back, oh, Mr. G had a Tynker that they had to do. And based upon what they did, the puzzle that they had to do in Tynker, they then received a clue to help them open a lock. And so when they started to create their own breakout boxes, they wanted to incorporate Tynker and utilize that. So any way that I can have students experience coding in other ways than just it's the coding time. We're fortunate enough that we have it built into our weekly schedule that there's about a half hour once a week that the students do some coding lessons. But I want to be able to bridge past that. I want them to see what coding can do, in every content area. I can have students present on a historical figure and have that historical figure, find an image of that and create your presentation in Tynker and have it look like that historical figure is delivering that information because I have it coded a certain way. And based upon the response that someone presses, if it's A, B, C, or D, we can then have your character talk about their childhood, talk about their accomplishments, what they're most proud of, their family, whatever you want to develop that into. You're able to do that through this platform and through coding.
Okay, so I see your Tynker allows you to increase student agency and student choice and creativity and
and just like with code.org, there's already pre-made lessons and curriculum that you can follow, but you can then add on to that and build upon that. And I think that's the powerful part of this platform.
Okay. I had a question right away. I was right on to my tongue. Oh, you were talking about where you create your own lessons. Do you share that out? Like, do you lead workshop? I know you're leading this session now, but do you lead workshops or training or professional development? Or do you share some of your lessons with teacher community or CS community?
I have not on a broader scale other than what I do within my district. So I'm on a team of tech facilitators amongst the different schools. And so we've come together and we've developed some activities that we then share out with our teachers. And I've led PD sessions with the teachers in my building on how they could utilize Tynker for, their own type of classroom assignments and projects where they could have a tutorial built in, or they could just simply, start the students off with the notion of, you're going to go on and you're going to create a program on Tynker that is going to be for our science lesson or for our math lesson. And this is what, I'm expecting, the expectations I have, and let the students go and start from scratch and start with a blank piece of, digital paper and start building their stage, adding their characters, and enhancing their presentation.
Now, I see, I foresee, because you're sharing about resources you can use kindergarten through 8th grade. So that's like elementary school and middle school, which we definitely need more resources, more support, and expanding, starting, building and expanding computer science programs on those levels. But I remember, because I used to actually teach middle school as well for a period of time, how this can actually be integrated in other teachers' classrooms. So those who are teaching other disciplines, have you thought about, maybe doing a training or professional development for the teachers in your school district, where they can integrate Tynker in their classrooms?
That's kind of where we've gone, where we've introduced, with the teachers, here's this platform that the students are going to be familiar with through their coding lessons that they do once a week. We can now add upon that. You can utilize the knowledge that the students are starting to get the foundation in with coding, and now start bringing that into different areas. I mean, I remember when I was a classroom teacher and I would do a presentation, have the students create a presentation, I would get 20, 25 PowerPoints or Google Slides. And by opening the door and giving the student options, you're going to have some students immediately gravitate to utilizing something like Tynker to be able to do their presentations. And so there it can be used in any content area. They can then set this up and kind of make it now more engaging and more interactive for an audience, so that when you do something like a gallery walk, I'll have the Chromebooks opened up, and as the students are going around checking out some of the other presentations, instead of just sitting there and clicking a button to advance the slides, now they have to interact with this program that a student has created. You're going to have a character ask you a question, and based upon your response, then determines where it's going to go in its program, so that you're able to have the students be more engaged in what they're learning. I would think, like for math, you're learning how to do multiplication, division. You can create in here, and the students are able to create in here an interactive component where they're able to ask someone, what would be the answer of 2 times 3? And if they can then have someone submit the answer 6, great. They see the character dance. And if the person enters in something else other than 6, we can have a condition set that something else happens. Maybe the program will start off with that character then talking you through 2 groups of 3. How many does that make? And gives you 6. And you can have your character moving around the screen and kind of almost like counting out how many are there. And with the fact that you can incorporate audio, you can incorporate movement, all of those different things, it now enhances that static presentation of looking at a slide and the images that are on that slide and the text that's on that slide, to now something where the person feels like they are driving the learning through the program.
Okay. Now, is Tynker free? Like the things that you utilize in your classroom, are those all free?
So we do have paid accounts that we utilize with the students doing single sign-on through Google. That way we have access to their full curriculum library, and we're able to utilize all of the different, as you can see on my screen, all of the different events and sensors and sound, all the different integrations that they have throughout the system. They even have different setups for different hardware. So like I have microbits in my building. I believe at our 5th grade, we have Lego Ouijoos. And so you're able to bring in those other pieces of equipment and do the coding in Tynker to be able to then save and upload that program to these other different items. And then they also have different game kits that you can kind of create a different platformer style game for the students to be able to experience and create and tinker with.
Okay. Now, because I haven't heard from McGriff yet. Is there? I saw you shared a code, but that was for like Nearpod.
Yes.
Is that integrated with Tynker? The code.
So Nearpod is just one of the platforms that we use in my district to deliver content, to deliver lessons.
Okay.
So like you have Nearpod, you have Pear Deck. There's a couple others out there. So we utilize Nearpod in our district. So I kind of utilize that to deliver my lessons for the students. And so I was able to incorporate a link to the Tynker activity and be able to push that out through Nearpod to the students so that they're kind of all starting in one place and they don't have to go and open multiple tabs and click on multiple different things to get different places. I can just kind of manage and facilitate my lesson through one platform.
Okay. And then since we actually have a lot of time left, is there a way for the people in the audience to actually just kind of sign up for the, I guess, free version of Tynker and try one of the free activities or something out?
Yes, that actually, I'm sorry to say, was what Leandra was going to cover in her time. I think she had some different codes and whatnot that they could go out and be able to sign up for, I think, an extended trial of the Tynker platform. But you can still go to tynker.com. You can still sign up for a free account, and you'll still have access to several of the features that Tynker has available.
Okay. Is the hour code one free? I was trying to remember because I actually attended one of the workshops a couple of weeks ago for they had a boot camp for APCSA. So
Okay.
AP, Advanced Placement Computer Science A. And I kind of liked their console with the gamification of trying to, start with some concepts, control structures and things like that. And I thought I saw that like our code was one of the free, at least, activities that teachers and students for which they can sign up. And I think there's another thing like that CSA one wasn't free, but I think they have a programming one that is free.
Mm-hmm.
And maybe
when you sign up for your Tynker account, you do have access to their resources. They have professional development videos. They have all of their hour of code available to you. Their help center. But what also is nice is they also send out weekly projects that, like for instance, right around Lunar New Year, this was one I did with 4th graders. There was one where you could code your own dancing dragon, and the students were able to have it set up, randomize the number of segments of your dragon, or you could specify how many segments you wanted and randomize the path that the dragon would go in, or you could have it set that it'll follow your mouse around the screen. And they had the ability to then go in and edit the costumes of your dragon segments. It was very well put together. And the nice thing is, it was already done for me. I got the email letting me know that this was available. I could click the button and assign it to my classes set up on Tynker. And since Tynker also nicely integrates with Google Classroom, which we use in my school, I was able to, with one click, pick which class I wanted to go to, and it already posted onto that classroom for the students, the link to that activity, and they were able to then do that activity. And so it was really nice that they have these pre-made activities that they send out to you that are timely with the events that are going on. So like when Mother's Day came up, when Father's Day came up, they had different things, activities already kind of pre-created that the students could then get a chance to try, alter, change, tinker around with, and be able to have that coding experience going with the seasonal events throughout the year.
Okay. So some of the people that are here now and potentially watching after this, the recording, are you able to browse the catalog so they can see like what, courses that are already out there? Because they might be new, mainly new to teaching CS, especially at the elementary school and middle school level. But some, they might not be ready to create their own activities yet. Not yet.
Of course.
So what are some places where they can kind of start and maybe if you're familiar, what are some of the concepts that are covered in some of those courses or activities?
So like, for instance, I have here with the elementary school plan, they've got 29 icon and block-based coding courses. The icon courses are like ones that can be accessed on an iPad through the Tynker app on the iPad. So like, for instance, this one is for pre-K to grade 2. It's kind of icon coding. It's a 10-course pack that I could then assign out. And if students are on iPads, they're able to do that. And then there are other courses that are web-based that students can access on a Chromebook or a laptop of some sort that you can then assign out. So the way we've done it is like, for instance, Space Cadet and Dragon Spells, we assign for our first graders. And so those are the coding lessons that the students get to do once a week. And as they go through and they complete those, we've also incorporated some from code.org, and then also the different activities that we push out throughout the year that we see from Tynker themselves. So like that Lunar New Year one that I did with the 4th graders. They had one for Mother's Day where you could kind of create your own Mother's Day card that was interactive. So we push those out throughout the year. And then like programming 1A, we do that for our 2nd graders. 1B, I believe we did for 2nd grade as well. And then programming 101 for 3rd and programming 102 for 4th grade. So like, for instance, if I go in here and I preview this, there's like 15 lessons, 184 activities. As a teacher, I'm able to go through, see what the topics are going to be covered, see kind of some screenshots of what it's going to look like. I also have the answer keys for each one of the levels. So if a student gets stuck, I'm able to quickly go in here if I don't understand. If a classroom teacher doesn't really know coding that well, they don't need to, because they can quickly jump in here. And like, for instance, storytelling, I can go in and I can see exactly what is needed for the knock knock joke. And so I'm able to see that sample project. And then at the end, I'm able to see what is needed for the student to be able to move on to the next level of that activity. I can go in, I can see individual lessons. I can either assign the entire course or I could assign particular lessons. So for instance, if I already know that my students are pretty good with creating like a slideshow, I can skip over assigning that and I can maybe move on to something else. And what's also nice is that if I have some students that are more advanced than what we've already figured for their grade level, I'm able to go back into this elementary school courses and I can then start looking down. Maybe I want to do something more in like augmented reality or math or English, and I can see what's there and maybe assign a lesson to an individual student to give them an opportunity to excel in what they're working on and what they're working towards.
Okay. Now, I know, I work for the Constellation Center for Equity in Computing. So one of the things we try to do is expand equity to computer science with the students not just access to those courses, and definitely those advanced courses as well, in computer science, but support and achievement in those courses. So with the Tynker platform and your experience, do you find that Tynker allows for equity in your classroom? Like, is that intent, and how does it kind of help with equity with your students, especially those that are underrepresented in this field?
I believe it does. With the fact that I look towards more of the accessibility side. The fact that the students are able, when I'm creating those tutorials, I can embed videos, I can embed audio, so that it doesn't heavily rely on you have to be a good reader to be able to go through those tutorials. So I'm able to bring that into it. It also recognition. So I get emails every now and then whenever a student has completed a course or completed one of the activities that I've pushed out. It kind of gives me kind of that award. So I'm able to go over and kind of recognize that student. Hey, here's that certificate that I can print out for you, so that they feel confidence in what they're doing and moving forward. And then I think the fact that, the diversity that we have with the different characters, the fact that they can bring in their own characters so that everyone feels represented. I believe, just looking through the images you're seeing right on the screen right now, the different characters that you can bring in, it is quite diverse, and everyone's going to feel like they are a part and can participate. It's not just the traditional, if you're looking at the screen right now, the program 100, that blue character there is like their mascot, but it's not like every activity is just that mascot. We can go in and we can pick anyone and be able to have them be our character and do whatever activity it is. And then, the creativity aspect of the students, they can get as creative as they want. If they want to, bring in, a cowgirl and have her talk to us about math, that could be our character. And that could be who's going to present the topic to the audience that they're programming for.
Okay. So, and correct me if I'm wrong, but I'm assuming that most of the programming is block based. Do the students have an opportunity to experience text based coding?
As you go through, you're able to move past the block based. So let me get out of here and let me go back into create a project. I'm just going to start blank. Here we go. That's what I was looking for. So when I go to start a project, I can either choose block-based coding, or they have these other coding languages that are available. So we have Python, JavaScript, HTML and CSS, Java, P5, JS, robotics, STEM. So they have a whole bunch of different areas that you can create a project in for your students. And so like if I went to Python here, I can create a Python project based upon some of the not tutorials, blanking on the word right now.
Concepts,
templates, some of the templates they have created and set up for you so that you can start working on those different coding languages. So as the students move up, so like for us, my K4 building, we're doing all block based. Some of the students in 4th grade start getting to a point where they're able to start doing some coding in Python or JavaScript. When they move on to 5th grade, they're coding in Python. And then I believe when they move on to the middle school, they do some more stuff in like Java. So we're able to build upon their knowledge and be able to bring the coding to them at their level throughout the different forms of code that they can incorporate.
Okay. And I'll end with this question. What would you, now with your experience with Tynker, what would be some suggestions you would have actually for the Tynker creators and developers and everything about the platform, curriculum, lessons? Like, what would be some things, ways in which you think they should add, could improve upon, or that's missing, or what have you?
One suggestion I've actually reached out and offered with Tynker was, when I was building a tutorial, I wanted to be able to embed other things than just a video, or to embed the block-based codes that they could use in the tutorial, or embed audio. Like, for instance, I wanted to embed, I have a Google slide presentation when I'm going over the key vocabulary like loops and conditionals and things like that. I wanted to embed that into the tutorial as a refresher. So if you needed to go back and look at the slides and the presentation that I delivered earlier in that unit, that would be there in the tutorial for them to be able to access and have everything in one place. When I did when I used Tynker and incorporated it with the breakouts, I wanted to embed a digital breakout on that page as an example so that they could see what the lock could look like that they're trying to solve for. Is it a number lock? Is it a word lock? Because you're going to need to know that when you're then coding, what's going to be the information that's going to be given back to your participant. Are you going to be giving them a 3-digit code or a word or something like that? I wanted them to be able to see where is this going to be leading to, thinking of the end in mind. So I want the ability to embed other items than just a video, audio, or the block-based code that you can drag out. And they thought that was a brilliant idea, and I know it was on their roadmap, that their developers are going to be looking at how they can offer the ability, when you're creating your tutorial as a teacher, have other things that you can embed into that for your students.
Okay, yeah, that's awesome. And they do have like auto grading, right? When you're going through some of the pre-made lessons and things like that.
So when the students are doing the courses, they do have built-in quizzes that will auto grade, and you can go into the teacher dashboard and be able to see where your students are and how they're doing.
Okay. So definitely, if you have anything else you would like to share, you can utilize this time to do that.
I would just say, make sure that you check out the teacher resources. Tynker offers webinars throughout the year. They have sometimes even done Twitter chats. They're always reaching out. I know you can also sign up if you're a classroom teacher, and let's say you have a unit coming up and you're just not sure, or you're struggling with trying to build an activity for your students. You can actually sign up for one-on-one help with a member of Tynker, and they have some different Tynker educators. I know one gentleman, big guy with a bow tie. That's from what his Twitter handle is, but he jumps on and he'll work with you through like a Google Meet and be able to kind of help you and guide you through something that you might not know that much in coding, and they're there as a resource to help. So if you have any questions or you're not sure of something, just reach out to Tynker support and they'll be able to connect you and help you out.
Okay. So I suggest for those that are watching, go ahead and use the remaining time to browse to Tynker and sign up if you haven't already for one of the free accounts. And then you can talk to your school district later about the paid account. But sign up for one of the free accounts and check out some of the courses, the level appropriate courses for your school. So yeah, that's what I would do next.
I think that's a great tip.
Yeah. So, if you, didn't want to stick around, we can go ahead and end here and just let the audience members peruse Tynker for themselves, or if you just wanted to demo something, we still have about 17 minutes, officially 17 minutes left. So it's all up to you.
And if anyone else has questions, go ahead and post them in the chat. Or if you want, we can even, I believe, have you join us on the stage to activate your camera and can ask them live.
Okay, I guess not. But that's okay. I know sometimes when people are at these virtual events, they're multitasking. Like
yes.
I was in a session with somebody yesterday, and we were put in breakout rooms, which is a new feature for Hopin, relatively new feature. And they were like, "Oh, I didn't know it was going to be interactive. I'm here babysitting," so they couldn't like put on their audio and video, hear all these children in the background making noise and stuff like that. But look, we understand. Go ahead and peruse. Can you put your contact information in the chat, and then
Sure.
that way if they wanted to email you or contact you via that way.
Easiest way to get me is on Twitter.
Okay, so put your Twitter handle.
I'm at Gallagher_tech on Twitter.
Okay, awesome. Yeah, I remember one of the beginning activities we did for the workshop was an Egyptian themed activity. I was like, okay. So not only were they teaching coding, teaching about history, teaching vocabulary.
Oh yes.
So I was like, I didn't even know that's what that was called.
Wow. This is so cross-curricular. You can bring in any content area you can bring into Tynker and bring coding into that content area. That's what I think is so vital for the students to be able to see that coding is everywhere and it can be utilized everywhere. That it's not just trying to have a character move from one side of the screen to another. You can have it show how to do math, talk about science concepts, tell us history. You can bring in so many different areas. I mean, the fact that we can have students take a story that they've read in class and add the next chapter, code the next chapter of the book. How would the story move on and continue? And now the students are able to have on your stage different settings that take place in the story. So if your character was, going to school and the school year ended at the end of the story, well, maybe they're going to a new school the following year. Show what that first chapter at that new school would be like. How would that character introduce themselves to their peers? You're able to bring in so much more through this one platform that it's not just basic coding lessons. The sky's the limit.
Awesome. So I know one thing I used to say is your only limitation is your imagination.
Yes.
Okay, well, great. We do thank you very much for joining us today and sharing the information that you have with Tynker. So awesome.
No problem. Thank you for having me.